Welcome to the WVU Shared Facilities Raman Microscope training module. In this training module, I will cover the basic operation procedure of the reinitial in-via Raman microscope spectrometer. The Raman microscope is located in the Chemistry Research Lab, room 381D. The entire system consists of the instrument itself on top of an optical table and a computer that operates the machine. Before you start your session, please make sure to turn on the laser in use sign next to the lab door to inform other users in the lab. Now let's take a look at the instrument on top of the optical table. Our Raman microscope consists of three basic components. The microscope, which will allow users to observe the sample and locate micrometer size region for Raman measurement. The laser excitation source used to generate Raman scattering from the sample. And the spectrometer that will collect and analyze the scattered Raman signal from the sample and produce the result spectra. Our Raman spectrometer is equipped with three laser excitation sources: the 532 nanometer green laser, the 409 nanometer UV laser, and the 785 nanometer IR laser. The current system is set to use the 532 nanometer green laser. The operation of the UV and IR laser will be covered in a separated training material. The output power of those laser sources are in the order of 100 milliwatts. That makes them Class 3B safety category, and safety goggles are required when operating the machine. You will be able to find those goggles in the lab. Now let us go through the system startup procedure. For microscope, you will need to turn on the microscope illumination source and the control box for the motorized sample stage. For spectrometer, you will need to turn on the main switch from the back of the machine. And for green laser source, you will need to turn on the power supply box from the back, then rotate the key at the front to activate the laser. Now let us take a look at the software part. Once we turn on all hardware components, we will need to go to the computer screen and start the Wire 3.4 software by double-clicking the software symbol. Then the software will ask you how to reference all the motorized components in the spectrometer. And here, make sure you choose Reference All Motors option. This will bring all the motorized components to their reference point, then move them to the desired position. The entire procedure will take about 1 minute, so please be patient. After this, we will enter the software interface, and we are ready to operate the instrument. The software interface has three areas. At the upper left corner, we have the image window, which will show the real-time image from the samples. Since our microscope is not equipped with eyepieces, you will need to use this image window to observe and align your sample. At the lower left corner, we have a set of buttons to set the laser parameters, including open and close laser shutter button, and a sliding bar that will allow you to adjust the laser power on your sample. Also another sliding bar that will allow you to defocus the laser on your sample if needed. There's another objective button that will allow you to input the objective information, which will create a correct scale bar on the image window. Notice that you will need to change the objective manually, while this button is mainly for the information. Then there is another set of buttons that will allow you to choose the spectrometer parameters according to the laser excitation source. By default, we are using the parameters for green laser source. You will need to adjust those parameters when choosing a different laser source. Again, the operation of UV and IR laser will be covered in a separated training module. Now let's go through some basic microscope operations. Our microscope is equipped with 3 objectives: the 5 times, the 20 times, and the 50 times objectives. All those 3 objectives are mounted on the objective turret and could be switched manually. When loading samples, I will suggest rotate all the objectives away to protect optics. To move the sample up and down to get the best focus, you will need to adjust the focus knob from the side. Our microscope is equipped with the coarse focus knob and fine focus knob for you to adjust the sample height to get the best image. Our system is equipped with a motorized sample stage. To move the sample in plane, you just need to use the joystick on the optic table as shown in this video. There are 2 big thumb wheels at the top of the microscope. These 2 wheels will allow you to change the microscope between visual alignment mode and the Raman measurement mode. When you set those 2 wheels to 2 and 1 from the top to the bottom, an optical image from your sample will be shown on the software, which will allow you to observe and align your sample. To perform Raman measurement, you will need to set those 2 wheels to down arrow and 4. After that, you will only see scattered laser light during the measurement, as shown in the images. Finally, I highlighted a thumb wheel at the bottom left of the microscope. This thumb wheel will allow you to adjust the microscope illumination intensity during the visual sample alignment, which is often needed after changing objectives. Now let's talk about the entire measurement protocols. We start with the sample loading and put your samples under the microscope. Then we will need to visually align the sample using desired objective and locate the region of interest, put it under the laser beam. You might choose any of the 5 times or 20 times or 50 times objectives to perform the measurement. In general, the larger the objective, the better the spatial resolution and also the stronger Raman signal you will get. Once you locate the region of interest, rotate the 2 big thumb wheels as instructed earlier to change the system from visual alignment mode to Raman measurement mode. Then set up the measurement using software and collect spectra. Once you finish the measurement, you could switch the system back to the alignment mode, then either go to a different spot from the same sample or change to a different sample. You need to put your sample on top of a glass slide for measurement. For bulk sample, you just need to drop your sample on the glass slide and make the surface to be measured facing up. For powder sample, please use a spatula to press your powder sample to form a nice and flat surface. To load your sample, first rotate the objective away and also lower the sample stage all the way down to get enough space for sample loading. Then you will need to mount the glass slides on the sample stage and secure the glass slide using a side mantle clip. After sample loading, rotate the objective back to observation position and start the visual alignment. For visual alignment, the image from the microscope will be shown on the upper right corner of the software window. You will need to manually adjust the focus knob and use joystick to move the sample in plane. This will allow you to obtain a sharp image and locate the region of interest. You should always start with the 5 times objective, which will allow you to locate your sample most easily. Once you have a sharp image from the sample using 5 times objective, you could focus on the edge of the sample or some regions with sharp optical contrast, then switch to the higher objective. This will make alignment using high objective much easier. When using the 20 times or 50 times objectives, the distance from the sample surface to objective is less than 1 millimeter. So you need to be extremely careful when adjusting the focus and should only use the fine focus knob to get the proper focus. Once you got the desired image, move the region of interest to the center of the crosshair, then rotate the big thumb wheel to down arrow and 4 position. Now we're ready for Raman measurement. The measurement setup starts from the Measurement tab, then New, then Spectral Acquisition. This will bring you to a Spectral Acquisition setup window. Under the Range tab, you could choose between 2 measurement modes, the static mode and the extended mode. The major difference between these 2 modes is the spectral range you could achieve. When choosing extended mode, you could determine the low and high wave number settings of the measurement, which is from 100 inverse centimeter minimum to 3,200 inverse centimeter maximum. Under the Acquisition tab, you could determine the measurement parameters, including the laser power to be used, the exposure time, and the number of accumulations. After selecting all the parameters, click OK button. Then this will bring you a blank window which carries all the measurement parameters. Then locate the Run button from the top menu and press it. This will open the laser shutter and start the measurement based on the selected parameters. Here we are running a scan on calibration silicon samples. The measurement is across the full spectral range we can achieve. Once the measurement is finished, the shutter will be closed automatically. If you decided to keep this scan result, just go to the File tab and choose Save File As and select the TXT format to save your result as a TXT file. If you choose Static Mode under the Range tab, you will only need to choose the desired center wave number of your measurement, while the total spectral range is determined by the acceptance spectral range of the grating, which is calculated automatically. Usually, you only choose this mode if you need to observe specific Raman peaks at known positions. For example, when you measure a silicon calibration sample to confirm the existence of the 520 inverse centimeter peak. Under the Acquisition tab, similarly, you could determine the measurement parameters, including the laser power to be used, exposure time, and number of accumulations. After that, press the OK button. This will bring you a blank window which carries all the measurement parameters. Then locate the Run button, click it. It will open the laser shutter and start the measurement. Once the measurement is done, the shutter will be closed, and then you could save the file into TXT format. Here I need to point out that if you want to make another measurement using the same parameters, you do not need to create a new window through the Measurement tab. Instead, you could just go to the existing acquisition window and run the measurement again. Then, the newly acquired spectra will be plotted in the same window on top with the previously saved spectra. Also, when you make Raman measurement, you will need to turn off the room light, so that will prevent the light contamination to your Raman spectra. Now we know how to perform a Raman measurement, but before measuring your own sample, you should always start with a silicon calibration sample to run a quick calibration, then confirm the performance of the spectrometer. Similar to other samples, you will need to load the silicon sample under the microscope, then perform the visual alignment using 50 times objective. Once you have the silicon sample aligned, go to Tools tab, choose Calibration, then choose Quick Calibration. The system will ask for confirmation of the sample alignment. Just confirm it, and it will start the quick calibration. After that, you will need to set up a static mode scan centered at 520 in worst centimeter and just choose all the default parameters. Then click Run. It will perform the measurement and just confirm the existence of the 520 in worst centimeter peak from the calibration samples. One possible issue you might have during the measurement is that the scattered signal is too strong for the detector to handle with the chosen parameters. If that happened, you will see the observed intensity suddenly drop to zero and the spectra turns from solid red curve into dashed red curve, as shown here. If this happens, you will need to abort the measurement, then set up a new measurement using reduced laser power and exposure time, and try it again until you get normal Raman spectra. To shut down the system, first, please close the Wire 3.4 software. We usually do this before shutting down the hardware, since if we leave the software on while shutting down the hardware, we will receive error messages for missing communication. Then we just simply follow the reversed order as the startup procedure. Turn off the laser key, shut down the laser power supply, turn off the spectrometer, turn off the motorized stage control box, and turn off the microscope light source. Now we could leave the instrument alone and finish up the session. We will still need to remove the sample from the microscope and clean the sample stage and optic table using clean wipes and IPA. Email the desired data files back to yourself. Please do not use personal USB to transfer data. Log off your session using kiosk program. Turn off the laser in use sign. Finally, ensure that the working area is cleaned up before leaving the room. This will conclude our training video.